Hi everybody, this is a video for PreCalculus. I wanted to provide a little bit of examples and some structure for talking about polar coordinates and polar equations. And if you're in our book for my class, we are talking about Chapter 8. This is Section 8.1 and 8.2. And there are some really good videos online in our course about how to be able to deal with polar equations and polar coordinates that are listed in our course. So you should check those out. This video is not meant to replace those. This video is meant to just add to those. And so you should watch those first that are available on our WebAssign course. And then after you've checked those out, this video should help kind of supplement some of the ideas or add to the ideas that show up in those videos. So if you haven't checked those videos out, go ahead and pause this and go run over and check out those videos first on WebAssign. If you've already checked out those videos, then you should have learned about how we can talk about points in our coordinate plane not just as x and y, but we could use r and theta. And just as a brief recap of what you've kind of seen from those videos, there are kind of four equations that you can use to talk about converting from a point xy to a point r theta. And you can use two other, so there's two equations to convert from xy to r theta. There's two equations to convert from r theta to xy. And really what they, my kind of few minute brief version of this is that here's where those kind of come down to is if you think about a right triangle, we have x and y, and then r is the length from the origin to that point. Sometimes that's later on in chapter 9 when we talk about vectors, that's going to be something called a magnitude. So these formulas are going to be really helpful in chapter 9 as well. And then theta is the angle right there. Now, I say right there, it depends on which quadrant you're in. So what I want to talk about in this video, because I'm not going to go into a ton of depth about kind of where these formulas come from and kind of, I'm not just going to recreate everything in the other videos. Here's the formulas, by the way, real quick, but I'm going to focus on some of the details of some of the nuances that could show up here. So if you know x and y, then you can find r using the Pythagorean theorem like this. And if you know x and y, then you can find theta by using the tangent of theta is equal to y over x. And notice, by the way, that this formula, this is going to be important, this formula does not say right now the inverse tangent. Now, we might use an inverse tangent sometimes in our problems, but what I want to focus on in this video is talking about being really careful about which quadrant your point is in. Because if you remember, the inverse tangent function is restricted to output values of quadrant 4 or quadrant 1. That should have gone along with test 2 that we just took before the break. If you think about kind of those circles and we talk about the inverse tangent is restricted to these right here. And so we got to be really careful. But the question is, what about if you have a point that's in quadrant 3 or a point that's in quadrant 2, and understanding how to find theta for that? You got to be a little more careful than just saying inverse tangent. So that's what we're going to see here a little bit in this video. These are two of the formulas you can come up with, but the other two formulas say something like x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. And those just come from your kind of SOHCAHTOA relationships in a right triangle. So these are the four equations you need to know for section 8.1. You need to know these for section 8.2. You'll need to know these for when we talk about vectors in chapter 9. Okay, so that's just kind of a brief kind of recap of some of the stuff you should have seen in the other videos. Please go check those out if you haven't already. Right now what I want to talk about is what happens if you have an r value that is negative. Okay, and then we'll actually look at what happens when you have a theta value that's negative, and then be careful about which quadrant you're in. So let's say you have an example where r theta is equal to, I'll just go ahead and use, how about something like negative 5, 60 degrees. Okay, now first of all, a question we could ask is, how do you graph this point? Okay. By the way, graphing polar coordinates, again, this is in the other videos. You can go to 60 degrees and then think about the polar grid as looking something like this that has a bunch of different circles on it, not our rectangular grid that has X and Y coordinates that have those kind of those boxes on a grid like you've been seeing for years. This looks more like a bullseye on a rectangular coordinate, and so you're saying go to 60 degrees, which means that this angle right here is 60 degrees. And then go out to 5 circles. 1, 2, 3, 4, 5 circles. Here is your point right there. Now you can find the XY coordinates of that point as well. Or I'm sorry, that would be this. I'm sorry, this would be the point if your coordinate was 5, 60 degrees. And so then the question becomes, is we wanted to look in a little bit more detail. What about if you have negative 5, 60 degrees? Let's look at these kind of side by side here. If you have negative 5, 60 degrees, again, you'd be working with kind of the same polar grid, which looks like a lot of different circles on here, looks kind of like a bullseye. Keep in mind I'm hand drawing this, so not the best drawn graph you've ever seen in your life, but you get the picture. Okay, so here's what negative 5, 60 degrees would look like. First of all, go to 60 degrees, so something right here, so you still have a 60-degree angle. And I know, even though the angle is listed second, you should probably look at that first because that tells you which angle to go. And then from the origin, instead of walking in that direction at 60 degrees, what the negative 5 says is the negative is not a negative distance, by the way. It's not really possible to have a negative distance. The negative there is more telling you which direction to go. So think about it like this. Think about there's like a person who is standing right here. There's my little stick figure. And think about standing on the origin and facing the 60 degrees. But now the negative 5 says don't walk forward 5 steps. Now the negative says walk backwards. So 1, 2, 3, 4, 5. Walk backwards 5 steps, and now you get to here. And this is actually where your point is. Okay, and so these are supposed to be about 180-degree difference from each other, by the way. It doesn't quite look like it, but that's what they're supposed to be. And so the negative r actually says instead of going in the direction you would want to go, turn around and walk backwards and go in the other direction. Okay, so let's think about what that means for something like this. Let's say you have the point r comma theta is equal to negative 3 comma, let's even get a little more creative. How about we throw in a negative angle measure, which shouldn't be a problem back from trig. Okay, so think about where negative 200 degrees is. And the question is, can you graph this point? Okay, so first of all, look at your angle. I would look at your angle first, even though it shows up second, because that's going to tell you kind of which direction to be facing. And then once you know which direction you're facing, then you can think about which direction should you be walking. Should you go straight if r is positive, or should you walk backwards if r is negative? So first of all, where's negative 200 degrees? Well, remember, I'll go ahead and use a different color. Remember, we're always starting from the x-axis, just like in trig. Go negative 200 degrees. So negative 200 degrees is an angle that gets you to about right there. Okay, so there's your negative 200 degrees. We went clockwise. And so, by the way, that means this little sliver of an angle over here is 20 degrees, but that's okay. And then the question is, what about this negative 3? So now that I have my little person who is facing this way, which direction should that little person walk? Okay, well, they shouldn't walk forwards because r is not positive. They should be walking backwards. And so, again, if you have your little grid in here, there's 1, 2, 3. I should be ending up somewhere right there as my point. Okay, maybe I should put that point in black there, make it stand out a little bit more. But there is our point right there because we're kind of facing 200 degrees or negative 200 degrees and then walking backwards 3 units. Okay, so it is possible to have a negative r value, and it is possible to have a negative angle. In fact, they could both happen at the same time. Okay, so I hope this helps for converting or for graphing polar coordinates. It should also help hopefully understand what does it mean when we have a negative r value. Okay, one more example I want to take a look at. This is a completely unrelated example to what we just saw. This is a different type of problem where C students tend to have an issue. we're going to see problems that say stuff like this. Convert to polar coordinates. Okay, and I'm going to give you a point that is already in rectangular coordinates. So we're converting to polar coordinates. We're trying to find r and theta. So I'm going to give you a point that starts out as x, y. And let's say I give you a point that starts out as x, y. I don't know, how about something like negative 5, comma 5. Okay, negative 5, comma 5. And the question is, how could you find r and how could you find theta? Okay, and if you remember back from the formulas that we had, let me go back to those a second, we're going to use these 4 formulas, and you got to think about which formulas do you want to use in which context. Okay, in this situation, you know x and y, and you don't know r and theta. So you should think about which formulas have both an x and a y in them. One of the formulas said r is equal to the square root of x squared plus y squared. Okay, and so in this case that means r is equal to the square root of negative 5 squared plus 5 squared. So we get something like 25 plus 25 inside of the square root, so this is the square root of 50, which you could write as 5 root 2 if you wanted to simplify. I don't really care that much that you do, but there you go. There's r. That's not too bad to be able to find r. Now the question is, what about theta? This is where I see a lot of common mistakes, because what we saw in the formulas earlier said that if you're going to use the formula that says r equals for one of the formulas, you might want to use the one that says the tangent of theta is equal to y over x for the other formula. And that's true. That might be a good formula for you to use. But if you're using the tangent of theta, if you're using the tangent of theta is equal to y over x, then what you would get is something like this. The tangent of theta is equal to 5 over negative 5, which that means the tangent of theta is equal to negative 1, which is true. This is true. But if you think about where is the tangent of theta negative, okay, the tangent of theta is negative in quadrant 4 and in quadrant 1. Okay, here's the problem with this. If you just have your calculator and you're just trying to kind of follow the formula, here's what many students are going to do. Many students are going to say, great, the tangent of theta is equal to negative 1. That means that theta is equal to the inverse tangent of negative 1. And this can be helpful, but there's a problem with this. If you remember what we said earlier, the inverse tangent is restricted to these quadrants. So what you're going to get when you do something like this is that it's going to tell you that theta is negative 45 degrees. But look at where negative 45 degrees is. That's in quadrant 4. That's this angle right here. There's your negative 45 degrees. What's the problem with that? Okay, look at where your point is. Negative 5, 5 as your xy coordinate. Negative 5, 5 is negative 5, 5. You're supposed to be up here, not down here in quadrant 4. But that's only because of where the inverse tangent is restricted to. You shouldn't be using negative 45 degrees. That's not actually your answer. What you want is the angle that has the same reference angle as negative 45 degrees, but you want the angle that's in quadrant 2. So what's the angle that we actually want? It's actually 135 degrees. Okay, but here's the problem. A lot of the time students just kind of plug stuff into their calculator and spit out what their calculator is telling them. You got to think carefully about which quadrant are you in. Boy, if you haven't learned anything in the last month in this class talking about trig, I hope that one of the biggest questions you've asked is, which quadrant is my point in? That is still true right now, even though we're moving on to material from test 3. Okay, so you need to be careful about which quadrant your point is in and make sure that your answer reflects that, because when you take the inverse tangent, you are only going to get something in quadrant 1 or quadrant 4. So you might say, well, how do I take my quadrant 4 angle here, the negative 45 degrees, and make sure that I get the right angle in quadrant 2? Well, add 180 degrees, and that'll give you the 135 degrees that you should have as your answer. Okay, please be careful which quadrant you're in. I hope this video helps. I hope you've enjoyed it.